Okay, next problem is going to be problem 17. So this is going to be number letter counts. So the numbers 1 to 5 written out in words are 1, 2, 3, 4, 5. Then there are 3 plus 3, so it's counting the letters, so there's 3 letters here, 3 letters here, 5 here, 4 here, and 4 here. Adds all these together, you get 19. Now it wants the total number of letters if you wrote out all the numbers from 1 to 1000. Inclusive, so we're not writing out 0 and we're not writing out 1001, but all the numbers in between, we're writing those out. Now this note's really important, so we don't count spaces, we don't count hyphens, and the use of AND is in compliance with British usage, so I'm just going to assume that how I know numbers, I'm going to assume that works. So, what we're going to do here is, so I get rid of this, I'm going to basically teach the program how to write numbers out in words, and then at the end just count the number of letters that it's wrote out. So, we're going to have some function that's going to take in a number, so we're going to have define right, we'll call this main, and then we'll just we'll put like our total here, so total numbers as words. This is going to be a list, maybe? Let's try this. Now we're going to have another function that is going to be letter or number to letter converter. This is going to take in a number and it's going to return a word. So the number is basically what this function is going to be the bulk of our program. It's going to take in the number, it's going to work out what the word of that number is and return that word. Now what we're going to do, we're going to say, like, in our main, so we want to do all the numbers 1 to 1000, we're going to say list of numbers is equal to an empty list. Now we're going to say for I in range 1 to 1000, list of numbers dot append I. So we're going to make a list of all the numbers. Now let's just do this and then print out list of numbers. We're also going to have to like pass in here or something. Actually, we might not need to do that since we've got a return in there. And now call main. So if I run this, okay, there we go. So we get all the numbers from 1 to 999. So because we want it to be inclusive, we're going to have to make this to 1001. And now you see we get 1000 in there as well. So what we're going to do now is, instead of printing this list of numbers, we want to say for I in list of numbers. We're going to say number as words, dot append, and then we want to append the number to letter converter of I. So what this is going to do is it's going to take our list of numbers and it's going to say for each number return for each number we're going to append to this list number as words. So this list that's empty up here, it's still empty so far, we're going to append to that the output of our new function down here, so number to letter converter. We're going to return whatever this outputs if we give it the input of I. So for example, in our list here, the first thing we're going to get is we're going to get 1. So 1 would get passed into our function that is down here and yet to be made. Obviously it's made, but like it's not got anything useful in it yet. So we're going to pass in 1 to this function. It's going to return something, so at the minute it returns word, and word doesn't exist. So let's just say this returns number. So it would return back 1, and then it would append 1 to our numbers words list. So that's useless at the minute, but it will be useful when we actually have something in that function. So yeah, so if I now put this back to Word, and now what we want to do is actually let me finish off the main function. So once we've now got this list of words, so that's the plan, that this list is going to be all the numbers that this list has, but just wrote out as words. So for example, it will start 1, then 2, then 3, and so on, and obviously this list will be 1, 2, 3, just like this. So you can see, hopefully this is what we're hoping to output. Now what we're going to do once we've got this list is we're going to say total letter count is equal to 0. Now we're going to say for I in number as words, total letter count plus equals len string I. Now hopefully that makes sense to you. So we're going to take I, so whatever's in here. Now it should already be a string. In fact, it doesn't make sense to return anything other than a string, so we don't actually need this converter in here, but yeah. So we're just going to say what's the length of the string that's in there, and then we're going to add that to our total letter count. Now we've got that, we're going to print out total letter count, and that will be our answer. So once we've got all this will output an answer. I am actually going to keep the string in here because I want to show. So at the minute, if we just return number, interesting. What is it doing? Why is it returning 4? So we have, let me just print out these lists. So if I go underneath this and I print out number as words, here. Okay. So what I've done, I've actually got these the wrong way around. It's meant to be plus equals, not equals plus. And if I do that and then comment out this list that I don't want to see anymore, there we go, that's better. So I'll get rid of this now, I don't need this. So what this is going to do, currently it's just got numbers in there, so this is just taking the length of the number. So you saw when the first answer was 4, it was taking the length of 1000, which was 4 characters. So this number right here isn't our answer, but what this does is it gives us the character count of all the numbers. So this is 1, and this would be another 1, so there would be 2 so far, then 3, then 4. Adds all these together, and that is apparently the answer. So we want a very similar thing, but instead of having numbers in there, we want words. Now we know that it's working properly, and it's given us the total properly. We need to sort out this function. So this function is probably going to be the longest one, and I'm not too sure what the best way to go about this is, but I'm just going to dive right in and we'll see. So first of all, what we want to do is we want to say string number is equal to the string version of the number we pass in. So we're going to need this to check which position the characters are in. So for example, if we pass in like a single number, so we pass in say 4, we want it to be able to detect that there's a single character in there, and then probably going to end up creating a dictionary, or maybe multiple dictionaries that will all contain different things that we need to know. So for example, do I need to create a dictionary? Yeah, this is probably best done with the dictionary. So if I could create a dictionary up here and then pass it in, that would stop, because if I create the dictionary inside this loop here, then every time this function gets called, the dictionary is going to be recreated, and it's just a waste of processing. So if I make a couple of dictionaries, so dict of so we're gonna have like our numbers all have a units column, a tens column, a hundreds column, and a thousands column. So the last number is the only one with a thousands column. Now, what we're gonna do is I'm gonna standardize all the numbers. So as these numbers come in, there could be any length. So there could be just a unit, so 1 length, or there could be 1,000, which is 4 length. So what we're going to do is we're going to say string number down here, and we're going to end up converting it to a 4-digit number. So obviously we're going to stick zeros at the beginning if it's just a 1. So the number 1 would come in, and it would come out looking like 0001 like this. Maybe that's my plan so far. We'll see if that changes. So we're going to have dict of units. That's going to be equal to, and we're going to have to fill this in manually, I think. So we're going to say that the key of 1. Actually, we need something for 0 as well. Wow, this is going to get complicated actually. A lot more complicated than I thought it would. Okay, so we start with 0. Now 0 is going to have no characters added to it because, for example, if you have the number 100, the units column is 0, and that 0 doesn't actually add any units. Add any word count. You don't say, for example, 100 and 0. You just say 100. You ignore the 0, I guess. So we're going to say 0 returns blank is what we're going to do. Now 1. That's going to be. I'm not even sure if I'm putting this into the dictionary right, but we'll get there. So 1 is 1. Now 2 is 2, 3 is 3, and so on. So this might take a little while, but yeah, not much else I can do about this. Pretty sure this has to be done manually. If you can think of a better way to do this, feel free to let me know in the comments. This problem is not very nice at all. Also really awkward to type out. Okay, so there's all our units done. Now we're going to need some more because we're going to need, so when there's like a number in the tens, so for example if we put 2 in the tens column, it's no longer a 2, it's actually a 20, so it has a different word count, so we're going to need a new dictionary for that. So yeah, let's get doing that. Now dict of tens. Now dict of tens, again if there's a 0 there, we don't say like 100 and 0, 10, 1 or something, we just would say 101. So the tens, that can 0 again can be blank, just like this. Okay, I'm going to leave the 1 out for now, I think, because if there's a 1 there, again this is a special case, so if there's a 1 there it might be a 12, in which case you don't say 10 and 2, you have like a combined word for that. This is why this is going to be so complicated. We're going to have to have like loads of ifs and stuff to hit like all these different exceptions, but okay, so I'm going to skip 1 for now, we'll come back to it. 2 is 20, 3 is 30, 4 is 40, 5, 50, Okay, so now we got that. We're gonna have a special dictionary for the teens, so the like the 10, 11, 12 up to like 19. So yeah, let's do that one. So what do we need for this? So this is going to be like a special case where if we hit a 1 in the tens column. So what my plan is, right, we're going to say like down here, we're going to say if like string of number, and we're going to say like the first entry is equal to like, no, that's not what we're going to do. We're probably going to have to say if the string of number and we're going to have to check that it's in our dictionaries. So we're going to say like string of number and we're going to set the first character. So let's, for example, we pass in, right? Let's say we pass in 123. So it's going to look like this. It's going to be 0, 1, 2, 3, right? Now we're going to say we're going to have at the beginning here word of number. And this thing is going to be what we return at the end. So the word of the number is what we're going to be returning. Now this is going to be empty for now. This is going to be an empty string. So what we're going to do is we're going to say for I in range len number, string of number. We're going to say word of number plus equals, and then it needs to see, this isn't going to work either. So we're going to have to say if string number I is equal to so we need to say if it's in something. Okay, so if it's equal to 0, no, this isn't going to work. We're going to say if string number 0 is in the, so we're going to have a dict of thousands as well eventually. We've got dict of teens, we've got dict. Do we need a dict of hundreds? We've got, so for the hundreds what we can do is for example, when you have 100, it's 1 followed by 100. So if there's a number in the hundreds, you would just say it's the same as the dict of units, so 1 plus the word 100. You don't actually need a new dictionary for the hundreds because there's no special cases. It's just 100, 200, 300, 400. Even if there's other numbers, like 367 is 300 followed by 67. So we don't need a dict of hundreds. Same as how we don't need a dict of thousands actually, because again it's just 1000, 2000. Okay, so what we're going to do, this actually makes things easier. So we're going to say if string number 0, we're going to say if it's not equal to 0, that means we've got something in the thousands column. So we're going to say word of number plus equals, so the word of the number is going to start out, if there's something in the thousands column, with the number of thousands. So it's going to be dict of units 0, I think. Is this right? We'll have to run this in a sec to see what this does. I can't actually remember if this is going to work right or not. And then word of number plus equals 1000. And we're not going to add any spaces in here because spaces will mean that we have to just strip them away later, since over here it tells us to, where is it? Do not count spaces or hyphens. So we're not going to worry about adding any spaces in here. So what I'm going to do, I'm just going to print out word of number, and instead of calling main, I'm going to call number a letter converter on 1000, and we're going to see what that does. So dictive units is not defined. Okay, so I haven't passed in any of these dictionaries up here. So yeah, let's get doing this. Okay, so okay, so I should have passed all these in down there. Oh. Right, third time lucky. Dictive unit is not defined. Fourth time lucky. There we go. So it's came out so far with 1000. It hasn't put the 1 at the beginning, which it should have. So we have to figure out why that is. So dictive units 0. This can't be right. So what we're gonna have to do, I'm gonna have a quick Google. I can't actually remember how to pull keys. Okay, so apparently it's get. I don't ever remember using this before. So dict.get. So dict.get. We want the key, so the key is going to be string number 0. Let me see if that works. Okay, I don't actually think this is right. Let me if we change this to okay, I get why that went wrong. So it's not dict, it's the it's dictive units. Can't convert non-type object to string. Line 26. What does this do if we do this? If we key error 1. Why is 1 an invalid? What about if I pass in? Right, okay, I get why this is. So, I can't pass in 1 as a string because, yeah, there we go. So, I can't pass in 1 as a string because up here it's an int. So what I need to do, I need to pass in string number 0, but then I need to convert this to an int. So if I say int right there, There we go. So we get 1000 now. Even though we got it up here, but obviously this was like just me typing in. So yeah, you can see that now works. So wow, that was confusing me. So what we've got now, we've got the initial step. So we've got it figuring out that there's 1000 there. So now if I pass in like 2000, it came out with 2000. Look. Now anything else, if I pass in like 2100, it's not going to pick up the 100 yet. It still just prints out 2000. We're not checking for the hundreds yet, but we'll get there. So I'm gonna keep this down here, and this is how we're gonna like code this bit for now, and then later on we'll just call main and it'll cycle through all the numbers and do them all. So what we're going to need now, we're going to need to solve the hundreds. The hundreds are pretty easy to do. So if there's if string number 0 is actually equal to 0, it doesn't matter, we don't need to check for that, because obviously if there's a 0 in the thousands column, you don't say 0,100, you just say 100, so don't need to do any more with the thousands now. So if string of number 1 is not equal to 0, then word number plus equals indicative units int string number 1, and then word of number plus equals 100. Whoops, not a hashtag. 100. So if I now do this 2100, this should come out as 2100. There we go, so 2100. So we're getting there actually. This is actually not as bad as I expected it to be so far, but I think the tens and the teens and the units might be a little harder. Well, the tens and the teens. So this is fine. 2100 is fine. You don't say 2100. So far we're doing okay. Now, next one, if string number 2 is not equal to 0, now we're going to need an extra if in here, because this is going to be our tens column. Now, if it's equal to a 1, we need to jump into this dictionary of teens. But if it's not equal to 1, so we're going to say if string number 2 is not equal to 1, then we can do pretty much exactly the same right here, except we're going to use dict of tens, and this is going to be a 2. So this would come out with the so this would come out with the thousands, this would come out with the hundreds, this would come out with the tens, assuming the tens wasn't a 1. We're going to handle the teens in a sec. Now, if there's something here, we need to add an and. Is it always an and? So if you have 100 and then you have something in the tens column, do you always put an and there? I think you do. The 160, for example, or 111, or 101. So and I can't think of anywhere where you'd have. Yeah, so almost certainly if this is not equal to 0, we're going to have an and. So we're going to say word of number plus equals and. Then we're going to add in the tens right here. So that's right. And then if not, we need to say elif string number 2 is equal to 1. So this is just going to be an else. Else we're going to say word of number dict of teens, and that should be here. Okay, so dict of teens, actually, so we need to come back to this part right here. I'm going to explain why in a sec. So dict of teens, I'm just going to fill this in now. So if we have a 0 in the teens column, then we're not going to worry about it because we're not going to have ever hit this thing. It's only ever going to be if we've hit a 1 in there. And now if we've hit a 1 in there, yeah, so when we jump inside the teens here, it's not quite as easy as what we've previously been doing. It's not quite as easy as this line. This line isn't actually right yet. The dict of teens, if we hit this, we're going to have to take into account the teens character. So on this number 1001, for example, we're going to have to take into account this 0 and also this 1, because obviously if something's a teen number, it's a 1 followed by a number, so 12, or it's going to be 15, or it's going to be 17. So that number's always going to be a 1. It's going to be the units column that decides what it is. So if it's a 1, we don't actually care about the dict of tens. Sorry, we don't actually care about the this number, the 2. We care about the 3, and we want to pull from the dict of teens that. So, for example, if there's a 0, yeah, so this is how we're going to do it, right? So if there's a 0, it's going to be 10. Now, if there's a 1, it's going to be 11, and so on. So hopefully this makes sense to you. 13. 14. I'm right in saying that is how you spell 14, right? Yeah, it is. Confused me because I obviously spelled 14 like this, but I would have also spelled 40 like this. 40. Maybe I'm just stupid. Whoops, 5. 15. So there's the dict of teens done. Now this here should work. Yeah, pretty sure this is actually okay now, and we don't actually need to change any of this, because if we hit the if we hit this thing, then this is going to handle basically the rest of the number. And we don't need to check units, whereas this thing right here, the thing I said we need to come back to, we need to handle units now, because if I handle units below like I planned on doing originally, if I say here, like if the string of number 3 is not equal to 0, this is going to mess up, because on the teens, so for example if the number ends in like a 12, then we don't need to handle the units, because the units are going to be handled right here as part of the teen number. We don't need to then add on like a 2 on the end. So we're going to come back inside this loop right here, and we're going to say, so once that's done, once this is done, if string number 3 is not equal to 0, then word of number plus equals dict of units int string number 3. So if it's 42, it's going to take a 40 from this bit right here, and it'll take the 2 from this bit right here. And we don't need any ands in there or anything, because it's not like 40 and 2. And I think that should work. If I just type in some random number right here. So 2,142. 2,142. So it gets that one right. Now let's see if they all work. 3,452. That one works. Now if I make this like a teen number, so 13. Okay, there we go. So we've got a key error now. So this is line 34, right here. Why is it hitting a problem in line 34 when it shouldn't be hitting line 34? If string number 2 is not equal to 1, and it is equal to 1, why is it jumping inside here? Ah, okay, so I need all of this to be in. So have I just been extremely lucky here and it's just... So what I'm thinking is the problem is that the string of 1 is not the same as the int of 1. So when it's checking this 1 right here, we've converted it to a string. It's taken string of number 2, which is going to be a string version of 1. It's going to say if that's not equal to the int version of 1, which obviously it isn't. So I think that might be our problem. And I think I've been extremely lucky so far that it's worked out. Okay, so pretty sure that should work there. Oh. Key error 3. Active. Ah, okay. Yeah, so dictative teens doesn't actually have anything filled in down here. I didn't fill it in, I filled it in up here. So if I just copy that one. There we go. 3,413. So 3,413. It gets that one right. Now I want to try something like 3,200 with none of the units in and stuff. So 3,200, that works. So this all seems to be working absolutely fine. So what I'm going to do is I'm going to comment out all this in case it doesn't work fine and we need to come back to it. I'm going to call main, and we're going to see what it prints out as the answer. Okay, string index out of range on line 28. 28 if... Ah, okay, so I forgot to make all the numbers that come in a 4-digit number. So what I'm going to do here, string number, get this. Now, before I do string number, I need to be changing, or do I do it after? I'll do it after, I think is the best way to do it. Now, if len string number is not equal to 4, then we need to hop in here and we need to append zeros to the beginning. So actually we're going to say, not if, we're going to say while string number, sorry, while len string number is less than 4. How do you add to the beginning of a string? Let me see that. Okay, so I was hoping there'd be like a special method for it, but it turns out there isn't, or at least it doesn't look like there is. The best way to do it is just we say we'd say string number equals 0 plus string number. Now, if I do this, let me print out string number here, and let me print out string number here, and then I want to break out of I'll just break out of this one, I'll just add this once. So it should only be doing the number 1. Yeah, so it takes in the number 1 and then it appends all these zeros to the beginning, and 0 is obviously the answer because this is all wrong with this breaking. Okay, so this should now work. Oh, whoops. Oh, please don't. Oh, that didn't actually take too long to run. So 20,791, is that the answer? Ooh, so it's not. So the answer right here is 21,124. So what are we missing? That's quite a significant amount. So we do definitely have all the numbers in, don't we? This could be it. So if we have okay, so if we have int string number 2 is not equal to 0, so this is the tens column. If the tens column is not equal to 0, we're going to add an and in, and that's the only way we step inside this. Now we actually need to be stepping inside this every time, I think. Because of the way I've coded these dictionaries, I actually think we should be stepping inside all of these ifs every time. And the only reason for checking if is for appending the and the 100 and stuff. Interesting. I don't actually think we need these zeros here either, but I'm going to keep them since it works. But I'm pretty sure that I've like excessively coded failsafes in that have then conflicted and caused each other to fail. So I think the problem is that when we've got a number such as 101, it's only printing out 100 rather than 101. So I'm going to check this now by passing in, instead of this main, I'm going to uncomment this stuff here. And I'm going to pass in 101. Yeah, so you see it's actually only found 100. It doesn't find that and 1 because the tens column's empty, so it doesn't step inside this loop, and therefore it doesn't hit any of the int stuff. So what I'm going to add is underneath this, I'm going to add an elif, and then we're going to have like a is it this bit right here? I think it's this bit. I think this is the bit we need. Let's copy that, pull this over, Does this work? So we've got 101 now. Now we need is there always going to be an and there? Let's just try it. This is really like, I'm not actually really liking this challenge because it relies on checking all of these cases. Sorry, this should be and like this. It relies on knowing all these cases of like how numbers should be written, like all the special cases. So for example, like the tens, I'd like find that out. So we got 101 here. This is working now. If I just comment all this out again and I'll run the main function, let's just see if it works. So 21,421. So not quite right, but we're getting there. I have a feeling now we're adding too many ands. So what could we be adding ands to that we don't want? So I have a feeling what we might be adding ands to is if. So I think we're hitting this because if the last character is not a 0. Actually, what are we getting wrong? Let's try some random numbers. So 111. That's right. 100. Let's say 11. Let's see what comes up there. Right. Yeah. So we're getting and 11. Now, the reason we're getting and 11 is because it's popping inside here. And it's appending this and even though it doesn't actually need to, unless. So it needs to append that and if there's previously 1,000 or 100. So if string number 0 is not equal to 0, or string number 1 is not equal to 0, and they need to both be ints. Oops. So if either of them are not equal to 0, then we want the and popping in there. Does that work? Line 36, invalid syntax. If so I've got plus rather than not equal to. Yeah, there we go. So we've got 11. Okay, let's try again. I'm also going to stop it printing out these strings of numbers because they're just spamming the console for no reason. Why is it still printing out strings of numbers? Print out. Wow, so my headset just died. I apologise for that. That might have been a horrible noise, I'm not too sure, but I'm sorry about that. Here we go, so 21,151. Wow, this problem! We are so close, but still not quite there. Okay, let's see what else could be the problem. So again, I'm gonna uncomment this right here. And we're gonna see what other numbers now fail. So what about 1? What does this do? We want to print out word of number. So now we're getting and 1. So this is where the extra ands are coming from. So we need this same if up here, this thing right here, we need to be down here as well. Let's go. So now we get a 1. Now is this going to give us the right answer? Actually, I'm pretty hopeful about this one. Let's go. 21,124. Yes! There we go. So 50 minutes to do 50 lines of code. Not bad. Not bad going. Pretty horrendous problem, but there you go. If you're stuck on this one, which I can imagine some people were, because this was pretty awful to wrap your head around. Then there you go. There's the answer. So we're gonna get rid of this. We don't actually need this anymore. Just neaten this up. There we go. So 44 lines of code and done. Now this would work for any length up to 10,000. Obviously we haven't closed in anything for 5-digit numbers, but we could say go up to 10,000, and I thought we'd do all the numbers up to 10,000. And if we get rid of this print that we no longer need. So this will give us the letter counts of all the numbers up to 10,000, so up to 9,999. And there you go, there's the letter counts of those. So if you wanted to add any more to this, all you'd have to do is just add a couple more exceptions down here, and obviously make this string number, rather than being 4 characters long, it'd have to be 5 characters long. But yeah, once you get into like the 10,000 range, you've then got the situation where this 10 now has to come from the addictive teens, whereas like if this was a 2, it has to come from like the addictive 10s. So you're gonna have to add like basically this entire code. You're gonna have to copy again, but for like a different placement of position. That'd be quite interesting actually. Like interesting enough to think about, not interesting enough to code, because this was horrendous. So yeah, thanks for watching. That's going to be the end of the video. I'm going to be amazed if anybody's made it this far and watched that whole video. But yeah, if you have, let me know in the comments below. I'll definitely be impressed. Leave a like if you liked it. Subscribe if you want to see more of these challenges done. And that's it for now. I will see you in the next video. Thanks for watching.